Hello, welcome to L.M. Robbins Company here in Slatington, Pennsylvania. Fabrication shop of L.M. Robbins and Bearing and Drive Solutions. Here at L.M. Robbins, we stock various manufacturers' conveyor belting in slab quantity, as you can see here. Full widths, up to 118 inch wide. And then we take those large rolls and we slit them down to whatever size is needed by the customer. Every belt is custom, and we're going to take you through the shop and show you all the fabrication that goes on here at L.M. Robbins. Here we are at the slitter. We have slitting capabilities up to 118 inches. This unit does 86-inch wide belts. Here we are taking a 20-inch wide belt, slitting it down to 18 inches. As you can see, the operator is setting up the blade at the correct width. And once that's set, he'll come back around from the outside and control the process. As you can see on the discharge end, the fall-off piece will fall to the floor. The width we are required to roll up will be threaded through the remaining rollers and onto a spool for portability. And from this point, the belt will go back into inventory and await an order to come out at this width, and then we will cut and fabricate to length. Okay, here we are at the Z cutter, the automatic Z cutter machine, where we take the cut to width or slit to width belt material, we load it into the machine, and our fingers will be cut with this machine. So our technician is loading in. He has pre-marked lines on the belt as to where it needs to be centered to. He's going to align that mark on the inside of the machine to be the center of the fingers. Then he'll lock that belt down in place and be ready to choose a recipe. As you can see from the inside shot, the head that is moving down and rising contains a blade, which is pressing through the belt and cutting the fingers or the Z into the belt ends. Depending on the belt thickness, this head will move faster or slower to ensure a perfect cut. Okay, now the belt has been completely cut across full width. The technician will come in after performing another task and check the fingers. This is the fall-off piece and the completed fingers. He's inspecting to make sure it's a good, clean cut. He will now reset the other side and cut the matching ends to make this belt into an endless piece. Okay, here we are at the vulcanization area of the shop. The gentlemen are going to bring the belt in, align the belt edges, ensuring that the fingers are gapped correctly and that the splice is in the center of the press. We affectionately refer to this area as cooking. In essence, we're using pressure and heat to cook or vulcanize the two ends of the belt back together. Welding is another term we'll use. Now they're making sure that the fingers are all fitting in nicely. These are long fingers and skinny, so we just need to make sure that they are locked in side by side. And as you can see, they are smoothing out nicely. next step will be to clean the splice area in the heat zone to make sure there's no dust, threads, or any debris in the splice area that will get sealed under the foil. This step is very critical, as I said, to make sure that there's no debris or marks in the splice area. Technician is now going to add the foil. This piece of material is the same material as the base belt. This belt is polyurethane, so the foil will be polyurethane. He'll place that directly over the fingers, and this is the material that will melt down through the fingers and bleed through to the bottom or underside of the belt, ensuring a good splice is achieved. Blocker pieces or extra belt material is used on the ends of the press as shims or blockers to ensure equalized pressure. The technician will now cover the whole area with a release paper. This release paper will make sure that the cover of the belt is either glossy or matte, so the entire belt has the same cover characteristic that's needed for the product. Okay, here we are putting the top of the press down onto the bottom press area. This is an air-cooled model. We're going to use heat and pressure. The technician is now securing the top of the press to the bottom of the press to ensure once this is pressurized, the foil and all the layers inside the press do not move. Okay, the vulcanizer is pressurized, and our technician is going to go ahead and turn on the control box. Ensure that the recipe that he's required to use for this belt is ready, and then it's just a matter of pressing start. And as you can see, the temperature in the press is already warming up. Once again, this press is air-cooled. It heats up quickly, cools down quickly. We'll be back in 20 minutes when the pressing process is over. Okay, so the press top has been removed from the bottom press. Our technician will now go ahead and reveal the splice, checking it out to make sure that we got a good seal. All the fingers are sealed. From this angle, it does appear so. He'll give us a thumbs up if it is. So now all he'll need to do is disassemble some more portions of the press, place a cutting board at the end so he can trim off these blocker pieces that were used just to ensure proper pressure. He'll use a straight edge to make sure that the edge of the belt is straight. And then he'll repeat this process on the other end. And then this now makes the belt ready to go to shipping and be sent out to one of our customers. Okay, here we are at the V-guiding station, where we're going to add a profile to aid in tracking of a belt. First, we're going to find the center or the spacing where the V-guide will be located on the belt. This particular belt's going to be centered. He then makes a mark with the straight edge to ensure all the sizes match up. We will then prep the surface of the belt using a grinder with light grit paper just to remove the skim coat of urethane or PVC from the underside of the belt in order to prep it for gluing and then the hot welding stage. Next step is to add the heat reactant glue. Okay, here we are at the automatic V guiding machine. The belt's already been prepped, glued. The glue has been allowed to drive. Now the technician will slide the belt into position, making sure that the wheel is properly aligned for where the V guide will be adhered to the belt on the center of the belt. This process is done with a heat gun. It will be warming both the belt and the V guide material at the same time. And once at temp, as you can see, it begins rolling and the guide is being welded onto the underside of the belt. A belt of this length will take approximately 4 to 5 minutes, and that is a 10mm guide going on, I believe. Okay, here we are. Scott is going to check the V-guide adhesion. We always quality check our fabrication to make sure the guide is in and completely finished to the belt. This particular belt is now ready for shipping. Okay, we are now at the lacing station where Aaron is going to load in some clipper lacing into the vise. There's a retaining pin he's going to force in to hold and retain the clipper lace in the jaws of the vise. And then load in the rough top belt that's been pre-skived. The ends are prepped, and we'll clamp this using a hydraulic press. Once and done is what's needed for this. We have it set for the correct tension. Ideally, we need to have the lacing crimp through to the underside. The tips need to fold over but not be protruding. It needs to be nice and smooth in that area. They look good from here. So we're going to move the lacer over and finish the opposite side. Very good. Okay, here we are at the final stages of the lacing. We're going to do a quality check, which involves making sure the belt ends lace together. We'll insert the pin into the splice, make sure everything is aligned perfectly. And he'll give us the thumbs up when it's proven. Looks good. All right, the belt's ready and off to shipping it goes. Okay, we do another type of fastener here besides the clipper lacing, and this one's the alligator plastic rivet lacing. We're taking this belt here and we're going to grind the edge and install, after punching holes, the rivet lacing. Okay, once he has enough rubber material removed, he will then take some measurements and punch some holes. And now he's using the template to locate the holes that need to be punched. Each fastener has 2 holes. All right, next step we'll be moving to the drill press. Okay, the last step here in the rivet lace is to put the belt end into the jig, insert the retaining pin that will hold everything together, and then this will get inserted into the alligator installation tool, which is a drill press with a curling bit that will mushroom the plastic rivet and hold or retain the lacing into the belt end. After ensuring a snug fit, he loads it into the installation tool. And at this point, he's curling over the plastic rivet that was extended through the underside of the belt. This style lacer is popular when a belt needs to be run through a metal detector. Maybe they're checking bags or boxes of food product for any metal or foreign materials. This plastic lacing will allow them to run it through the metal detector and not be picked up like the metal lacing would. This lacing is installed in a light duty material, as you see in the video, but can also be installed in the lightweight European style belting, the thin 2-ply polyurethane or PVC styles. And that finishes up the full width. Here you can see close-up shot of the mushroomed rivet plastic lacing in its completed stage. Okay, we're back here in our grinding station area. This is the portion of the shop where we prepared nylon core belts. Nylon core belts are used in power transmission and the folding carton box industry. It's comprised of carboxylated rubber or just plain rubber or elastomer on the covers, top and bottom of the belt. Sandwiched in between is the strength member, which is made out of nylon, hence the nylon core belt. What our technician is doing now is applying double-sided tape to the edge of the plaque, the portion that will go under the grinder, to bevel or skive the overlap portion of the belt end. Both belt ends will be skived to match perfectly when put into the press. As you can see now, he is lining up the edge of the belt onto double-sided tape, making sure it's secured, locking down the material on the end before the process of the machine takes over. At this point, he's going to load the plaque into the grinder. When it bottoms out in the home position just before the grinding begins, we'll stop and then start the grinder. This process takes typically 5 minutes, but it's an automatic grinder and provides a perfect grind each time. As you may be able to begin to hear a high whine of the grinder wheel coming in contact with the rubber surface. You'll see there's some blue dust coming out from under the yellow shield. That indicates we are getting a grind. Okay, the grinder is complete. We're now going to open it up, shut down the motors, and see what we have. Looks like another perfect grind to me. Okay, here we are at the vulcanizing of the nylon core belt. Terry's going to load this in and make sure that the skives are lined up properly. The very critical part of this process, when you're welding nylon core, the layers that were skived need to match up perfectly. What the solvent does is softens the nylon area to allow the opposite ends to weld together during the heat process. So he's just checking to make sure that everything is lined properly. Then he'll make some gauge marks to identify the correct placement of the ends once he's ready to lock everything together, and after the belt is coated with the solvent. The masking tape will help with the alignment process, as he'll make little thin lines for alignment purposes. You'll notice in this process we are also using blockers to fill out the portion of the press where the belt is not, to ensure an even and equal pressure zone. Now he has everything lined up, so he'll dismantle and pull that end out, and then begin adding the solvent. After the solvent is applied, there will be a rubber cement also used. This step includes making sure that the solvent is put on and covers the entire nylon core area, but is not put on generously. Liberal use of the solvent is required, as too much will wick in under the rubber and soften the nylon area outside of the heat zone. So great care is taken to put just enough in the right areas. Now he'll prepare the opposite end, which will be overlapping the bottom portion that's already locked in place. Years of experience allows Terry to know by feel and look if the correct amount is used. Okay, we're back here at the welder for the nylon core. We had to wait a couple minutes to allow the solvent to do its magic. And now we're going to apply a rubber cement to the ends that will hold down the blue rubber material during the process of vulcanizing. And this is only applied in the blue area, not overlapping into the black or gray nylon core area. As you'll note, both ends are treated with the rubber cement, same as the solvent. Okay, now it's time to put the belt together. Now you see how important those lineup marks are. Once this belt goes together, it needs to be put together and placed in perfect the first time. He's now locking in the other belt end, and we'll be ready to close up the press. Top release pad goes in. This is made of silicone. And then an equalizing steel sheet or plate. And then the top of the press unit goes on. Similar to other vulcanizers, this has a top and bottom heater. We'll pressurize this press, and it is water cooled. We're now pressurizing. He'll choose the correct temperature or recipe for this particular belt. Press start, and it will begin heating up. This process will take approximately 20 minutes. Okay, we are now ready to disassemble the nylon core press. We've removed the air pressure and hoses from the unit. We're going to strip the top heating platen off and then disassemble the equalizing sheet and the release sheet to uncover the finished splice. Both lockdown bars are removed, and we're going to inspect the belt and clean up the edges. There's some slight overflow of the solvent that is pressed out of the belt due to pressure. And then as a finishing touch, we'll take some 80 grit sandpaper and further clean up the overflow. This belt is now finished with the splicing process. And if it's a full width belt going off to the customer, it will head to shipping. If it's a belt we spliced in full width, and then we'll need to slit into smaller, possible 1-inch wide belts as a match set, the next step will be slitting. Otherwise, we'll move this on to shipping. Okay, we're over here at our Gerber cutting table. This is a static table, uses vacuum to hold material, and we can cut various shapes, turn belts, vacuum belts. We can also cut fingers in for splicing. As you can see now, Josh is going to navigate the menu and look for the item he's going to be cutting on the table for this particular job. Once he finds it, I'll highlight it and it'll bring up all the parameters. We can see now that that is a perforated belt with fingers cut into the edges. And this is what he's going to be cutting. So he'll select that, send the job to the unit, and we'll pick up at the table watching the cut. Okay, here we are now. We have the fabric loaded onto the Gerber cutting table. We're going to move the cutting head into position. Just want to remind you or let you know that we do take all the measurements and load it into the system ourselves. We do not take any patterns offline. So this allows us to confirm that the belt that's being made for a customer, we've measured, we've entered the information, we've designed the pattern, and then once the belt gets shipped out to the customer, we will then make sure that we have a successful or proven pattern, and then we'll mark or highlight that in the system that it's a good pattern to use moving forward. If the customer tells us we need to tweak something, we'll make the adjustments. But otherwise, we'll have a proven pattern, and this will be ready to go with just a click of a mouse and a quick setup here. So we're going to go ahead and turn on the vacuum system and let this start punching. It's going to be a little noisy. Okay, we've loaded a turn belt recipe into the cutting table now. It's a blue material. We're going to be cutting a large 180-degree turn, I believe it's going to be. What we're doing right now is justifying the material, giving the Gerber cutter a start point and end point of the material, and then it will start cutting once it gets back into its home position. This will take a few minutes. It will cut the fingers into the belt, and it's ready to rock. It is now cutting the inside radius. And we'll move on to cutting the other set of fingers on the opposite end of the belt. Okay, the cutter's going to go back to its home position and allow Josh to remove the outer portion of the belt, or the inner portion, making sure that all the cuts are successful and we have no hanging chads. A process making a turn belt like this would be a half-day affair, using the old utility knife and patterns, tracing. Now this was cut out in a matter of minutes, and it will be exact and perfect every time. We can repeat this recipe several times a day, or in 5 years, go back to the same recipe, recall it, and make this belt again. Isn't she a beauty? Okay, we're in the back of LM Robbins shipping area. We're gonna send out some of today's finished belts. I hope you found today's video very informative. And if you have any questions, please reach out to your nearest representative, and have yourself a great day.